In this video we'll be looking at logarithm fundamentals and the common and natural logs. So first, the meaning of a logarithm. What does it actually mean? Well, in this form here it's asking the question, to what power must b be raised, b is the base here, in order to produce x, in order to produce this x right here. So we'll refer to the loop rule. It's called the loop rule because you make a loop like this and then it becomes an exponential. B to what power will equal x. So the base raised to this power, that's the bottom part of the loop, b raised to the question mark power in this case, equals the x. So there's your loop. So b to what power will equal x. That's what the logarithm is asking. So, or what the definition of a logarithm, what it means. So evaluate log base 2 of 8. So with that said, log base 2 of 8 equals what? So 2 to what power will equal 8? That's what we're saying. 2 to what power will equal 8? Well, 2 cubed is 8, so that means this logarithm is equal to 3. And then you can check it. Use your loop rule here. So 2 cubed needs to equal 8. 2 cubed needs to equal 8. Check. That's right. So log base 2 of 8 is equal to 3. The answer is 3. Alright, let's look at example 2. Okay, evaluate log base 3 of 81. So log base 3 of 81 equals, so in other words, 3 to what power will equal 81? So 3 to what power equals 81? 3 to what power equals 81? Well, 3 to the 4th is 81, so this logarithm, the answer is 4. So 3 to the 4th equals 81. Check it. 3 to the 4th equals 81. Yes, that's right. Your loop rule shows you this part down here, and we're done. So the answer is 4. 3 to the 4th is 81. Therefore, log base 3 of 81 is equal to 4. Use that loop rule to check each time, going back to your exponentials. All right, let's look at the next two examples. Alright, example 3, you've probably noticed this already because we've been doing it, but exponential equations can equivalently be written in logarithm form, and logarithm equations can be equivalently written in exponential form. So write the equivalent of y equals 4 to the x in log form. So let's write it, y equals 4 raised to the x power. So here is the way that I describe it. So the base is 4 here, right? So the base of your logarithm will be 4. So we'll put log base 4 over here, and everything else crosses over. So this x crosses to this side of the equal sign over here, and this y crosses over here to this side. So it ends up looking like that. Okay, so the base is the base, the base is the base, everything else crosses. So the x comes over here to this side, the y comes over here to this side. And now we can use our loop rule to check. So 4 to the x is supposed to equal y. Yes, that's right. So these two are equivalent. This is the same thing as this. This is in exponential form. This is in logarithm form. They are equivalent. All right, let's look at example 4. Just scroll down here and look at that one. Write the equivalent of y equals log base 2 of x in exponential form. Okay, so same thing. We'll put our equal sign here. The base is the base, and everything else crosses. So the y comes to this side and the x goes to this side. So x equals 2 to the y is equivalent to log base is equivalent to y equals log base 2 of x. Okay, we can check it with our loop rule here. So 2 to the y is supposed to be x. 2 to the y equals x. Yes, everything works out. So this is equivalent to this. Logarithm form, exponential form. Everything's the same. Base is the base. Everything else crosses. That's one way that you can look at it to help you keep this straight. Main thing is check it with that loop rule and make sure they are equivalent when you're done. Alright, let's look at the next section. Alright, in this section we're looking at the common log and natural log. So when you see the term common logarithm, that means a base 10. So in other words, if this is a little wordy here, but all it's saying is if you see this right here, this part right here, logarithm 386.7, there is no base listed. There is no base listed here, but it's implied to be 10. Okay, so if you just see log like this and no base is listed there, it's implied to be the common logarithm, which is base 10. Over here on this side, when we worked with exponentials, you recall that we worked with exponentials that had a base of e. Well, we're going to have logarithms that have a base of e. And if the base is e, they're called the natural logarithm. And instead of writing it this way, log base e of 187, we use this, ln, natural log. You can remember that ln is natural logarithm. Makes sense. There's an ln in there to keep that straight. And just realize that log base e of 187 is the same thing as ln of 187. You can technically list it either way, but this is the most common. So if you see this, oftentimes when you're working with these problems, you'll end up converting it to this form because you can apply your loop rule and things like that from this. Just keep in mind that ln is log base e. All right, now let's look at the change of base formula here next. So occasionally it is useful to change a logarithm in one base to an equivalent expression using a logarithm of a different base. So one clear example would be your standard calculator will do log base 10, the common logarithm, or log base e, the natural logarithm, but it won't do anything else. So in some cases, if you're trying to use your calculator, you can use this change of base to help with that in certain cases. So the formula, change of base, is log base a of x is equivalent to the new base b here. So log base b of x over log base b of a. So notice that a is the original base and b is the new base you want to go to. So make sure you're clear on that. And the way that I often explain is in this section here, you're writing it with the new base that you want. And if you look at the way this is written, the x here is a little bit higher than the a here. The a is a subscript, right? So that the a is going on the bottom, the x goes on the top. That's one way you can look at it. Just a little trick to remember it. The x is a little above, so it goes here. The a is the subscript below, so it goes on the bottom. All right, so let's work example 5. Express the common logarithm, so that means log base 10, of 13 in terms of natural log. So right now we have log of 13. There's an implied 10 right here. We don't have to write it, but it's there. And we want to write that in, I'm going to list the 10 there just so you can see it. And we want to write it in terms of natural log. So we could write this in two ways. Log base e 13 over log base e of 10. Okay, so notice what we did here. The lower part went here, the upper part went here. Now, the same thing, we've talked about this in the previous section there, that log base e is the same thing as ln, so this would be ln 13 over ln 10. Either way is fine. This is the most common way to list it. All right, let's look at example 6. All right, now to example 6 here. So it says evaluate these without using a calculator. Bases cannot be negative, so this is the base, and we can't take the logarithm of a negative number. So this, called the argument of the logarithm, cannot be negative. So we can't have negative bases, can't take the logarithm of a negative number. Okay, so we have log base 16 of 2. So log base 16 of 2 equals what? So first thing we'll do is we'll use our loop rule and convert it into an exponential. So 16 to the x power equals 2. And then we have an exponential with a base, technically a base of 2 over here raised to the first power. So we want to, just like when we solved exponentials in the previous unit, we want to match up these bases. So 16 I can rewrite in the next step as 2 to the 4th, still raised to the x power, equals 2 to the first power. Okay, these are equivalent. 2 to the 4th is 16, and still raise it to the x power. So now you apply your exponent rules outside to inside here, multiplies. So coming up here now, next, we have 2 to the 4x equals 2 to the first. Now we have like bases, so we take those exponents and we set them equal to one another and solve. So we have 4x equals 1, divide by 4 here, and finally we have x equals 1/4. So the answer is x equals 1/4. And remember, when we discussed solving exponential equations, I told you we would see this again in the logarithm unit. So it's an important process to be able to follow. All right, let's look at example 7 next. All right, example 7, we have log base 4 of the 4th root of 8. Okay, so the first thing we're going to do is convert that into an exponential. So 4 to the x is equal to the 4th root of 8. Well, I'm going to do this in a couple of steps. So next, I'm going to leave this the same, 4 to the x, and I'm going to make this 8 to the 1/4 power. Remember, in our exponent unit, it's power over root, so we're raising 8 technically to the first power. We don't list that exponent here, but it is there. So power over root, we're taking the 4th root and we're raising it to the first power. So this is equivalent to this. Okay, now just like when we worked with exponentials in the last unit, we need like bases. So we can rewrite 4 with base 2 and we can rewrite 8 with base 2. So in the next step coming up here, that's what we're going to do. So 4 is 2 squared raised to the x power still. So the 4 is this 2 squared and we're still raising to the x power here. That is equivalent to 8 is 2 cubed still raised to the 1/4 power. Now we have like bases, but we still need to apply our exponent rules. So outside to inside multiplies here, outside to inside multiplies here. So 2 raised to the 2x power is equal to 2 raised to the 3/4 power. 2 times x, 2x. 3 times 1/4, 3/4. Okay, now we have like bases, so we just take those exponents, set them equal to one another, and solve. So we have 2x equals 3/4. Divide by 2. Dividing by 2 is the same thing as multiplying by 1/2. Since we're working with a fraction over here, that's what I'm going to choose to do. So finally, the answer is x equals 3/8. All right, that is it for this lesson and this video.